Welcome back to Geometry, Measurement, and Probability. In this video, we will continue our discussion of measures of variation. And primarily, we will focus on the variance and the standard deviation. So let's get started. As we said in our last video, we often use a measure of spread to help us better describe our data, specifically when our data are summarized with a single number such as the mean or the median. Now, our simplest way to find our measure of variation is to find the range. And we talked in our last video about the interquartile range as well. The most sophisticated measure of variation is our standard deviation. So variance and standard deviation are two commonly used statements of dispersion. Now, specifically, these measures tell us how far our values are from the mean. So how do we find the variance and standard deviation? Here's how. First, we need to find the mean of our numbers. Second, we subtract the mean from each number. And then we square each difference that we found. We find the sum of the squares. Now you'll notice that I use a table to complete steps 2, 3, and 4. We divide our sum by our number of values to find our variance, and variance is represented with a lowercase v. Then we take the square root of our variance to find our standard deviation, and standard deviation is represented with a lowercase s. So our standard deviation is the square root of our variance. Look at example 21. We have some scores from Professor Abel's class, and we are asked to calculate the variance and the standard deviation for these scores. First, we need to find our mean. To find our mean, we add all of our values together, and we divide by 6 because we have 6 values. The sum of our values here is 360. Divide by 6, and we get a mean of 60. I use a table to help me complete steps 2, 3, and 4. In my table, I have an x column, an x minus x bar column, and x minus x bar squared. So the x column is for my data values. I list those values in no certain order. My second step is to find the difference between my value and the mean. That's the second column of my table. So I say 100 minus 60, which is 40. Then 80 minus 60 is 20. 70 minus 60 is 10. 50 minus 60 is negative 10. 50 minus 60 is negative 10 again. And 10 minus 60 is negative 50. The sum of this middle column should always be 0 or very close to 0. Sometimes because of rounding, you might get 0.1 or negative 0.1, but the sum of that middle column should always be very close to 0. My third step is to square each difference. That's my third column. So 40 squared is 1600. 20 squared is 400. 10 squared is 100. Negative 10 squared is also 100. Now be sure when you type negative 10 squared into your calculator, you put that negative 10 in parentheses. Remember, anytime we square a negative, we always get a positive. Negative 10 squared again is 100, and negative 50 squared is 2500. Add that last column, that's our fourth step, and that gives us a sum of 4800. For our fifth step, to find the variance, we take the sum of that last column, which is 4,800, and we divide by 6 because we have 6 values. Our variance here is 800. Our last step is to find the standard deviation, and we take the square root of the variance, or the square root of 800, which is 28.28. Now read your directions carefully in math labs to be sure that you round to the correct number of decimal places. So here our variance is 800 and our standard deviation is 28.28. Let's look at another example. This time we have the scores from Professor Babel's class. Again, we're asked to find the variance and the standard deviation. My first step is to find the mean. So I add all of my values together and I divide by 6 because I have 6 values here. The sum of all those values is 360. Now make sure as you type this into your calculator that you either go ahead and find that sum of 360, or if you type it into your calculator all at one time, that numerator needs to be in parentheses. 360 divided by 6 is 60. Make your table with your x column, x minus x bar, and x minus x bar squared. X is my data values. I do not have to list those values in any certain order. My second step is to find the difference between the value and the mean. That's my middle column. 70 minus 60 is 10. 70 minus 60 is 10 again. 60 minus 60 is 0. 60 minus 60 is 0. 60 minus 60 is 0. And 40 minus 60 is negative 20. The sum of this middle column is 0, and it should always be very close to 0. My third step is to square each difference. That's my last column of my table. So 10 squared is 100. 10 squared is 100 again. 0 squared is 0. 0 squared is 0. 0 squared is 0. And negative 20 squared is 400. The sum of that last column is 600, and that's my fourth step. My variance is the sum of that last column, 600, divided by 6 because I have 6 values. And so we have a variance of 100 here. To find the standard deviation, I take the square root of 100, and the square root of 100 is 10. So my variance, represented with the lowercase v, is 100, and my standard deviation, represented with the lowercase s, is 10. Many times in statistics, we deal with what are called normal distributions. These are bell-shaped curves, also called normal curves. Now, specifically, a normal curve is a smooth bell-shaped curve. It depicts our frequency values, and these values are distributed symmetrically about the mean. In a normal distribution, the mean, median, and mode all have the same value. The curve keeps on going infinitely in both directions. It gets closer and closer to the axis, but it never actually reaches it. And our curve is symmetrical. Now, not all symmetrical curves are normal, but all normal curves are symmetrical. You'll notice in your notes that you have a picture of what we call the empirical rule. There is a change that we need to make to this picture. This bottom number should be 99.7, which means the two ends are 0.15%. On a normal curve, about 68% of our values lie within one standard deviation of the mean. 95%, or about 95%, lie within 2 standard deviations of the mean, and about 99.7% lie within 3 standard deviations of the mean. These percentages are based on the area under the curve. So how do we use this? Look at example 23. We have a standardized test with a mean of 500 and a standard deviation of 100. 10,000 students took this test, and their scores make a bell-shaped normal distribution. So how many students scored between 400 and 600? First, I need to know how far away from the mean are 400 and 600. So I subtract 600 minus 500 and 400 minus 500. Now notice that both of these are 1 standard deviation, or 100, away from the mean. A positive value is above the mean, and the negative value is below the mean. The percent associated with 1 standard deviation is 68%. Change your percent to a decimal. Move your decimal place 2 places to the left, gives us 0.68. And we multiply by 10,000 because there were 10,000 students who took the test. And we get that 6,800 scored between 400 and 600. Look at part B. How many students scored between 300 and 700? Again, the first thing I need to know is how far from the mean are each of these values. So I subtract 700 minus 500 and 300 minus 500. Notice that I get 200 and negative 200. Again, a positive value is above the mean, a negative value is below the mean. 200 is 2 standard deviations away from the mean. Since the standard deviation was 100, 200 is 2 times 100, or 2 standard deviations. The percent associated with 2 standard deviations is 95%. Change your percent to your decimal. Move your decimal place 2 places to the left, gives us 0.95. There were 10,000 students who took the test, so I multiply by 10,000, and that gives me 9,500 students who scored between 300 and 700. Look at part C. How many students scored between 200 and 800? Again, the first thing I need to know is how far from the mean are each of these values. So I subtract the mean from each of these values. This gives me 300 and negative 300. Again, a positive value is above the mean, a negative value is below the mean. 300 is 3 times 100, or 3 standard deviations. Look back at your chart on the previous page of your notes, and the percent associated with 3 standard deviations is 99.7%. Change your percent to a decimal. Move your decimal place 2 places to the left. Gives us 0.997. Multiply by 10,000. Since 10,000 students took the test, gives us 9,970. Look at part D. On part D, I want to know how many students scored above 800. So again, I need to think about how far from the mean is 800. So I say 800 minus 500 is 300. 300 is 3 times 100, or 3 standard deviations above the mean. So I look at my graph from the previous page, and I'm going to count from my mean x bar in the middle, 1, 2, 3 standard deviations. And I'm looking above that, and notice we have that 0.15%. Change your percent to a decimal. So move your decimal place 2 places to the left, gives us 0.0015. Multiply by 10,000, tells us there were 15 students who scored above 800. So how do we use the normal curve? Well, let's suppose that a group of 200 students asked their teacher to grade on a curve. The mean is 71 and standard deviation is 7 here, and our graph shows how our grades could be assigned. Look at your table. So these grades are assigned based on our normal distribution. The last thing that we have in this section are what are called percentiles. These are often used with our standardized tests like ACT or SAT. A percentile shows a person's score relative to other scores, and a percentile divides our data into 100 equal parts. The rth percentile is represented with a capital P and a subscript of R. So let's suppose you take a standardized test and you score in the 86th percentile. What does this mean? Well, what this means is that 86% of the test takers scored below you. Now, our second question is this. If 1,000 people took the test, how many people scored below you? So I take the 1,000 and I multiply times 0.86. I change that percent to a decimal, and that tells me that 860 people scored below me.